Welcome back. I got a comment asking if I could share some of the redstone contraptions that would be useful when making an escape room in Minecraft. So in this video I will be going through a bunch of different circuits and redstone things, just how different components and all that work, and just some tricks near the end. So I've laid them all out here. We'll be going through them one by one. And this will be a longer video, so I'll have the outline down in the description, so you can click on that to jump straight to wherever you want to see. So let's get started. First, we have the basics. The basics of a redstone signal. If you're not aware of this, a signal is how much power is going through the redstone. So if I flick on a lever or any power source, that will provide 15. If you hit F3, you can see this entire data screen here, and on the right side you can see where it says power 15. So the source of the power causes the power to be 15, and as it moves through the redstone, every block it moves away, you can see it's 14, 13, 12, it drops 1. So the redstone can only go 15 away before it fades away. Now if I didn't have this repeater here, this is 1, 0, so there's no power here anymore, so this lamp is not lit up because no power is getting to it. One of the things that a repeater does is it magnifies the signal. So if there's just power 1 coming into it, it will push out power 15. So I have an example down here to show that off. If I replace this with redstone dust, you can see that we flick this on, and that lamp is so far away that the redstone fades out about here. So if we want to make it the rest of the way, we put a repeater down and it'll extend the signal. So this goes back up to 15. So you can see 1, this is powered true, and this is 15. So because of that, the signal is able to make it all the way down here. So if you have a long, redstone thing, you need to get power from here to way down there, you need to use repeaters. That's one of their functions. There are more. Another thing to note is that blocks can be powered. So in this case, the power is going into this redstone lamp. So this block is powered. If we put redstone here, we can see that the repeater is pushing the redstone power through there and lighting this up. If we turn this off, we've got a lever on a block. So right now the lever's off, so there's no power getting here, but if we turn the lever on, it powers the block, powering the redstone next to it and turning on the lamp. You might also notice that this torch is turning off. So a redstone torch by default, if I just set one down over here, it's just on. It's on all the time unless you make it not be on. So it's on, but if the signal goes into this block it's on, it will turn off the torch. And that's a very useful thing. We'll get into it a little bit later. Another thing repeaters can do is they can cause delay in a signal. So if I put this down, you can see there's an arrow. Real quickly, another thing is that they control direction. So if I put power here, it won't go through that way because the arrow's pointing that way. But if you put power here, it'll go through the direction of the arrow and get through there. But the other thing it can do is you can right click on it to set the delay. So everything in Minecraft goes by ticks, which is a fraction of a second. Having redstone like this right here, if I put this redstone torch here, there is 0 delay between that torch being placed and this being lit up. As soon as there's a power source there or any power comes into there, goes through this, no delay. But if you go through a repeater, that automatically introduces a 1-tick delay. So it's a very small delay, and so if you have something that's sending signal really far away, it is going to have some delay to it, which normally isn't a big deal, but if you're trying to get your timings right for different things, you may have to introduce more delay at various points to compensate. But you can use this to your advantage. Maybe you have a signal. Maybe once I flick this lever on, I want the lamp to come on after a few seconds instead of right away. Or, anything could happen. But so if I flick this, you can see that that lamp turned on automatically, and that had the lights, the redstone slowly got through and turned on the light. And if you turn it off, it'll also do the same thing. The lamp on the right will turn off very quickly. The lamp on the left, we'll have to wait until the redstone signal dissipates from each of the repeaters in turn. So you can see it propagating through there and how much slower that is. So that's one way to introduce delay. Next we have comparators. This is what a comparator looks like. When you place it down, there is an arrow pointing which direction it faces. So just like the repeater, if power goes in here, it comes out here, but if power goes in here, it won't come through this direction. It's one directional. It has two modes, the normal comparator mode when you place it down, and the subtraction mode, which we'll get to in a little bit. In comparing mode, one of its main features is that it can read how full some sort of container is. So this chest has all these spots. If I put a whole stack of something in there, you can see it has one redstone signal coming out. It doesn't go up to 2. There's no power there. And this is actually, if I just put 1 in, so 0, it has 0 signal coming out. 1 item in there, it has 1 coming out. And then at certain other thresholds, you can see now it's got 2 coming out. This can read other stuff. We can have a chest, or we can have, in this case, a hopper, which has 5 slots. And so the fractions, you can look them up, but it's based on how full this hopper is. So you can see putting the same amount of items in the hopper makes the redstone signal go a lot further than it did in the chest. And it's based on the stacks. So these stack to 64. If I put a wooden sword in there, that doesn't stack at all. If you grab a sword and try to put it on top of there, you can't stack them. So putting that in there makes the signal go up more than, the same amount that an entire stack would. So boom. Now that's completely full because we've got 2 full stacks, and these are all considered full stacks because the stack can hold 1, it has 1, so 1 of 1, it's a full 1. So the signal goes all the way through and lights up the lamp. This can also detect the fullness of a cauldron. And a cauldron, if you put 1 water bucket in it, that's 3 bottles of water. And so it'll go 1, 2, 3. We take 1 out, it's down to 2. Take 1 out, it's down to 1. Take 1 out, it's empty and down to 0. Another thing that comparators can read is an item frame. So this item frame is on this side of the block and the comparator is on the other side. And yet if I put something in here, you can see that there's a signal strength of 1. And if I was to take this out of here, there would be no signal strength coming out. But if I right click on this to rotate the item, you can see that there's more and more redstone signal coming through. But there you go. This is the fullest rotation it can go. So you could have something that looks at different signal strengths. You can have like a repeater coming off of here. So if the signal strength is at least this, then this goes off and does something. Comparators can also read books on a lectern. So this is a book I have. Let's see if I can take a book. Ooh, there it is. So this book has 15 pages. You can see there. So what this does is when it's on here, it can tell which page it's on. Right now it's on page 1. So this is again out of the total number of pages. So if you want this to work where every page puts out 1 more signal strength, then you need to have 15 pages so that the math works out properly. So you put 15 pages in here, and as I flip this, you can watch that redstone signal go up. You can see 2, 3, 4, so you can see it getting further over there. So now it's rounded the corner. And if you have it all the way at 15, then it gets through and it lights the lamp. The other thing about lecterns is that if you connect this up here, every time you turn a page, it outputs a redstone signal. So every time I turn a page, the light turns on. So you can use lecterns in either of these ways in a redstone circuit. A comparator has 2 modes. When you first put it down, it's in comparator mode, and when you right click, it's in subtraction mode. So what do these do? In comparator mode, if you have redstone coming into the back and to the side, it will compare the signals. So let's get a repeater here, or a torch. A torch puts a signal of 15 through. So what this is doing is it's saying, what is this compared to this? As long as this is greater than or equal to the side input, then it will output the same value that's coming in the back. So if we make this one greater, or nope, if we make this one less, that's how to do it, then no signal strength is coming through because this is 15 and this is only 14. So because of that, it's not going to output anything. So it's comparing the signals. Now, if we put this in subtraction mode, what it will do is it will take whatever is coming in through the back input and subtract what's coming in the side. So in this case, 14 minus 15, it's 0. It doesn't go into negatives, but so it has nothing coming out the end. Whereas if we were to, oops, make this like this, now we've got 15, 14, 15, 14, 13, and just to show you, yeah, that's 13, 14. So 14 minus 13 is 1, so that's the signal that comes out the front. Here you can see that these lecterns, we can control what the inputs are. So we set this to 3. This is in compare mode, so as long as this 11 is greater than 3, then it will output the 11. So we can have this go all the way up to 15, and the light turns on. And even if this is all the way at 15, the light will stay on because 15 is greater than or equal to 15. That's true. But if this drops to 14, this would override it and no signal comes out. Also, even if we drop that, 14 isn't quite enough to get to the lamp. If we were to put this in subtraction mode, you could see now it's doing 14 minus 14, which is 0. But if we lower this to 13, you can see it's got 1. So in this case, by having it in subtraction mode, we could, every time you flip the book back a page, the signal gets larger and larger. Over here we have a daylight detector. So this detects based on what time of the day it is. Right now it's noon. It outputs different signals. So in this case it's power 15. At noon, daylight detectors happen to put out 15. And you can look up a chart online to see what signal strength they put out at different times of the day. Or you could just experiment and figure it out. But this daylight detector is outputting a signal of 15, which means it's lighting the lamp. Here, if we change the time, so now it's earlier in the day, the sun's over there. You can see here it says time set to 1000. So the signal strength now, it's outputting 10, so it doesn't make it to the lamp. This over here, just in case you don't know what these are command blocks. So you can type any commands here. So if I type a command in the chat, you can just type /, which is on the same key as your question mark. Then you can type commands. Like this is where you can change your game mode from creative to spectator. If you hit tab, it'll go through all the options you have there. But you can also do time set day, or you can see there's day, midnight, night, and noon. So command blocks, oops, what they do is you put a command in them, and when they receive a redstone signal, it executes the command. So this way I don't have to type time, set time, day, noon, etc. And to get these, you can't find them anywhere in the creative menu. So you need to /give your name command block. Boom. Now I have a command block. I can set it down. I can time set day, and then if I give it a redstone signal, you can see it does whatever I told it to do. These can be really useful and do a lot of cool things. I've played around with them a lot in the past. In my escape room, I'm trying not to use any command blocks. It's all redstone that's connected. I think it's more fun and interesting, and I think there's a lot of shortcuts that you could use if you're using command blocks. So if you want to look into that and save yourself some time, but I don't think it's as much of a challenge or as interesting to do. But that's just my opinion. My friend was looking at one of the things I was trying to work on for the escape room, and he said, "Do you just hate yourself, or why are you not using command blocks for this?" And that's just a sneak preview over here. This is something I was working on. This is going to obviously need brought down a lot smaller, but all of this, he was saying, well, if you use command blocks, it'd be a lot easier. Maybe, but less interesting. The reason we have these time changers is so that we can test the daylight detectors. Last season of Hermitcraft, ZF built his Cave of Contraptions, and as part of that, because he was in a cave, he couldn't see the sun. So he had a sun detector sort of thing. So the light lit up, so we had lamps lighting up where the sun was in the sky. I went into a redstone testing world because of that, and I figured out how to do it myself, so I was building my own version of it. Fun little project and challenge. And as part of that, I created this little circuit here. Nothing too flashy, but basically what it does is it takes the signal from this daylight detector, and this is going to set the minimum and the maximum and feed it through an AND gate. So as long as whatever the current thing is, which is currently 15, as long as 15 is greater than whatever this is set to and less than whatever this is set to, and it's inclusive, so these could both be set to 15 and it would work. As long as both conditions are met, the lamp turns on. So in this case, our maximum needs to be 15. Our minimum can be whatever, because 15 is greater than 10, and 15 is less than or equal to 15. So since both conditions are met, boom, the light turns on. And we can change this to be different times. So we can see at nighttime the lamp's not on because these conditions aren't met. These are outputting a 2 because there's some sun left. It's not quite all the way down, so they're emitting a signal of 2. So if we wanted to drop this, the minimum needs to be 2 or less. And in this case, now 2 is greater than or equal to 2, and 2 is less than 15. So the lamp turns on. You can also change these to be nighttime version mode, whatever you want to call it. So you right click on it and it inverts it, so now it's detecting nighttime. So it's kind of interesting, but you could go and during the night you could set these to nighttime and then figure out this is power 11, so at some certain point of the night I want something to happen, and use the same thing for that. So this is just a minimum, maximum, little circuit. An observer is a block that reads the state of the block in front of it and outputs a redstone signal if something changes. So when you place one, the arrow will be facing you. This is different than a repeater where the arrow is facing away from you. So if I place down a repeater, the signal is going that way. Whereas if I put down an observer, the redstone will come this way. I don't know why it's backwards, it just is. If you look at the other face of it, it's got a little face, a little stoic guy, and he's watching right here. So if I change this, he will see that, and he will output a signal. So this can be used for a lot of things. Here we're going to use it to light that lamp, turn it off. You can see the pulse is so quick, and pulse is what we call it when the redstone turns on and then off. So in this case the pulse is really quick, and in some situations we want it to be less quick. If you've seen the chess video, I think I demonstrated this a little bit, but if we have a piston, a sticky piston, and a block, normally if I power this and unpower it, the sticky piston will pull the block back. That's the whole point of it being sticky. But if we have this powered by an observer, the signal from the observer is so quick that the piston, even though it's a sticky piston, will extend the block and then it'll unextend, leaving the block behind. So this is just a quirk of pistons and observers. If we wanted this not to happen, we would need to make the signal just a little bit longer. One way to do that is with a repeater. So if I put this through here, we can see that it's got a different signal. So let's try it with a block there. You can see it extends and unextends and keeps the block the entire time. Whereas this is too fast, this slows it down a bit. Real quick, a use for observers in farms is if you have sugarcane here, it'll grow and it'll pop. As soon as it gets in front of the observer, by growing up high enough, the observer will detect that there's something there. It'll power the block behind it, powering the redstone beneath it, powering the piston, which extends and knocks the sugarcane down, and you can have something to collect it. it's not dropping anything because I have the game rule off for dropping entities, otherwise I'd have entities all over the place. Another way to extend your signal is this little circuit here. So a comparator, one of the great things about them is that unlike a repeater, where if I put a signal of 1 in the back of it, it'll strengthen it to 15 and put it out. A comparator will take whatever signal comes in the back of it and just push it through. Same signal. So when I power this, let's just see it in action before I explain it. Boop. So you can see the redstone fades away and the lamp turns off. So what's happening is the power starts at 15 and then goes through as 15, but every time it goes from here to here or here to here, it drops. So every time it goes around this track, it's going to drop 2. So it's going to be 15, 14, 13, 12, 11, and it'll slowly go down and down and down and down, where the comparator is keeping it from the signal from doubling back on itself. That's why you need the comparators. So it pushes it through in one direction, but doesn't strengthen it. And so you can see it slowly gets less and less and less power. And this target block is another great addition to Minecraft. So normally, if I had just like a normal block here, you can see the redstone signal isn't going into it. The redstone isn't feeding into it, so it's not going to light the lamp. So we'd either have to, put redstone on top of it, which would work, or we could have, redstone come in the, nope. You'd have to go all the way around to get it to feed into there. So it's just a really annoying thing to do, and target blocks save all of that, because the target block will automatically make the, the redstone next to it go straight into it. So just by putting that one block there, it solved all that work, which is great. Now, sometimes instead of making the signal longer, we want to make it shorter. So a lever, if you put one of these down and you turn it on, the output will stay on forever until you turn it off. Then it's just off. Where if you had a button, it would turn on and then off. It would be a pulse. So maybe you want to make a lever function more like a button. So what we're going to do is a pulse limiter. Under this block we have a sticky piston, and when this is powered, the repeater will push the power through the block, through this repeater, and light up the lamp. But it will also, this being on, will make the sticky piston extend, meaning the block's no longer there for redstone to go through. So if we see in action here, boom. You can see the lamp turned on and then off. This block stays up here because this keeps the piston extended. And when we unpower this, the piston can drop, but there's no longer any redstone to go through. So only when I turn this on will it flash that, and then when I turn it off, nothing happens. So it turns a long signal, a continual signal, whatever, any kind of signal, into a short pulse. Okay, toggles and latches. I've got a definition here. A toggle changes the output state of, or changes the state of the output on to off or off to on. So you've got a signal that's off. A lever is a toggle because it turns, you click it, changes the output to on. You flip it again, it turns it to off. A button is going to put out a pulse, whereas a lever just changes the state, and then you have to do something for it to change back. A latch is something that remembers the state on or off, and we'll get to that in a bit. So here's a button, it does a pulse, boom. A lever toggles on, it's going to stay on until I flip the lever again. So here we have a latch. So this is going to set and reset, because this block, if it's over this redstone torch, will be powered and will power this redstone lamp. So all I have to do is push this button, it'll push the block over, and now it's lit. If I push this button, nothing else happens. It's already set, it can't be set again. And to undo it, we would have to reset it, which is just a piston pushing it back. So this is a latch because you hit it once, boom, it's set. and the only way to get it back is to reset it. So you could have something where a player does something, maybe they solve the puzzle, and you want the door to open, and you don't even need the reset part. You just need a piston to push a block into the way. Boom, now the door's going to open. They can do the thing again. They can undo it. Maybe it was putting a book on a lectern caused this to happen. They take the book away, the door's still open, whatever. Something like that you want to happen, this would be a great example of it. And if you ever need to reset it, maybe they go in another room, something else happens, and it causes it to go back, or maybe you just want to reset it so that the escape room is ready for the next person, then you can push this button to reset it. And pushing the reset button, because these are just normal pistons and not sticky pistons, pushing the button over and over again won't do anything. So if the player accidentally gets to the reset before they get to the set, nothing bad's going to happen. Right here, what we have is a toggle. So this will turn the output on and then off every time I have an input. So I push the button, if I can hit it, boom, the lamp's on. Even though the button is no longer powered, the lamp still stays on. I can push it again and it'll turn the lamp off. So every time there's an input, it changes the output. It just alternates back and forth. It toggles between on and off. And the way this works is these are all three droppers, and that's a hopper. So this dropper has an item in it. When it's powered, the dropper will push it up, this dropper will push it over, the hopper will drop it down. Which sounds complicated, but all it's doing is putting the item in here. Now that it's here, this comparator reads that there's something in there and outputs a signal of 1. This repeater will take that signal and make it 15. So I could have this block right here and just that would work fine. But if you want this signal to go anywhere, you're going to need a repeater to, push out the signal, extend it so you can get somewhere with it. And then here's the item. You can see if I push this, the item switches back over here. All right, let's build one of these real quick. So you can see I've got a couple built here. Not very hard. Let's see. I'm going to need a comparator. Why not? And I'm going to need like a button probably. Okay, so when you're building this, let's say we want the signal to go that way, the way we're facing. So we're going to place one down facing us. We're going to jump and put one facing up. We need one facing back this way. Just by the way, if you ever need to open, or you need to place a block on something that would open if you right-clicked, you just crouch and then you can place something on it. So this works for hoppers, chests, anything that opens or does something when you right-click, like a crafting table. You need to place a block on the side of it. Just crouch and right-click. So we have a hopper. We can crouch and right-click on the top of here, and boom, there it is. We need a comparator feeding out of this dropper here, and then we'll extend the signal, and we'll just have the signal come over here so we can see it. We're going to put a repeater right here and a button right here. So there we go. Oh, I need an item. Boop. So now when I push this, the item goes through. It's now in there. When I push the button again, it ends up back here. What we have here is a memory cell. So this is a latch where when a signal goes in, it stays on, and you'd have to reset it for it to turn off. So it's just like the set reset, but it doesn't use pistons. I found that pistons can be unreliable at times. They can mess up and do weird things. They're not completely consistent. Really nothing in Minecraft is, but they're less consistent than repeaters. So if I wanted to do something like set and reset, I could use repeaters instead of pistons. And this is called a memory cell because it stores whatever the input is. You would put you put a signal strength into it, it stays on. You turn it off, it stays off. It just stays at whatever you want it to. So if you're making some sort of computer, like I was building an 8-bit computer in Minecraft, and I used a lot of these memory cells to be able to store information, the ones and zeros that it needed to operate. What you do is you push this button, it'll put the signal on and lock it in place. If I push this again, nothing will change, and then if I reset, it'll turn back off. This works by a feature, which is pretty cool, of repeaters, where if you have a repeater feeding into the side of another repeater, it will lock it. So you can see if I put this here, the torch that's normally on the back here turns into a bedrock bar. Now, the signal for this, if I try to give it a signal, nothing will happen because it's being locked out. If I get rid of this, it'll unlock it, allowing it to pick up whatever signal it is. I lock it again. Now it's locked on. If I get rid of the input, it still stays on because it's being locked right now. So let's build one of these circuits here. Alright, what you need is a repeater feeding into it. We're going to need a block here and a torch. So this is going to stay on all the time unless the circuit is powered. So it's always going to be locked in whatever state it's in. It stays off, it stays on unless it gets powered to change. You can have your output coming out here. Here we'll need a repeater because when we go to reset it with this button, we don't want the signal coming back and changing this again. Let's see, we'll do this here and we'll have a button. So now if I push this button, the signal will go through here, turning off the torch. Let's change that to a lever so we can see what's happening here. And you'll notice it's not working right now, and that's because of a timing issue. Because we've got a repeater here adding 1 tick of delay, that's adding a tick of delay. I think maybe that adds a tick of delay. We need to set this a lot further so that when the signal comes through, it's locked before the signal, falls off. So if we change this to a lever, we can see how this works. The power is going through here, powering the block, turning the torch off, unlocking this repeater, allowing this signal to go through. And when we turn off the lever, all that goes in reverse, locking the repeater back in whatever state it was on. So now it's locked on. If we want to reset it, we push this button, which will just unlock the repeater. And like I said, we have this repeater here so that the signal can't go through, because if it was like this, the redstone signal would come back here, and so it would just get locked on every time you reset it, which is obviously not what we want. So we'll have that facing that way, and reset, set. And a lot of times you'll have to experiment with timings. You might have to see what this needs to be. So if it's all the way there, you can see that this clearly will not work. So maybe it can work there. Yep, works just fine there. Another thing we've got here is, not sure what to call this one, but this one is just switching inputs. So you can see that currently this input is on. If we push this button over and over again, nothing will happen because it's already selected. If we select the other option, it'll switch. That lamp will be on and that one will be off. So only one of them can be on at a time, and no matter how many times you do the input, it won't change until you do the other one. And this is a really simple little circuit. So you put 2 blocks down, you put a redstone torch here and here. You have redstone that comes from that torch and then goes on top of the block the other torch is on. Do the same thing on this side. So whichever one you put down first, that's the one that's going to stay on, because once this is here, turns off this torch. So all it takes for this torch to come on is for that torch to turn off, because that's what's keeping it off. So if I were to power this, that turns on, turning off that torch, allowing this torch to turn back on and lock it in place. So it just switches back and forth. Alright, let's talk about clocks. Sometimes you want something in your circuit where it'll power on a regular sort of thing. So you can do this a lot of ways. One of the simplest ways is to have just some repeaters, put some delay on them. We'll put some redstone here, and then we'll introduce and remove a signal. So the redstone slowly goes through, there's a delay, so it takes its time going around here, and you could have something set to the output here, like maybe if I had a lamp on me. Boop, boop. It'll just turn on. So you could have this. This is a very basic clock. Nothing wrong with it. And you can always add more repeaters. I could have a whole line of repeaters and have 2 little redstone at the end, and then have a whole line of repeaters coming back, 2 redstone over here. But it's not very compact. There are different ways to do clocks. So here is a very fast clock. Not very fast, but yeah, decently fast clock. If you want faster clocks, there's a couple ways to do it. One is, I think, give me an observer. Oh, that's far away. If we were to do this, can't remember if I already explained this earlier, but the repeaters are looking at each other, and so when that one sees that this one was placed, it turns on. When this one sees that that one's turned on, it turns on. So that just goes back and forth, causing a clock, a really fast clock. The problem with lamps is they take, I think, 2 ticks to power off. So because this is so fast, the redstone lamp doesn't even have a chance to turn off, so it just looks like it stays on the entire time. But if you had something else, you know, these boop, 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 really fast clock. Let's see. So this is a decently fast clock. This is easy to make. I guess I could show you how to do that. So we're just going to make a little V formation here. We'll have a repeater here. I think on full delay. We'll have a torch here and a redstone dust here. So what happens is this torch is powering this block, goes through the repeater slowly, comes down here, powering this block, turning off the torch. And it just goes around and around and around, and you can feed this into whatever you need it to. And then, as you see here, you can put a lever on it if you want to turn it off. So I don't want it on all the time. Turn it off and on as needed. So we'll turn this one off here. Here is an example of the repeaters. You know, if I put a signal in here, it'll just slowly go through and light that up. Not really that special, but totally viable for a lot of applications. If you want something a little more sophisticated, this is the hopper clock. So what happens here is you have a stack of items here, and you can have as many items as you want. You could have this be just a few items, you could have this completely full. A hopper will automatically try to suck the items from the hopper above it, and if there was a chest here or something, some sort of container, this would be trying to push its items into it. So this is 2 functions. So if I drop a whole stack in here, this will try to suck it out. If I power this, it will stop sucking it out because it's powered, so it turns off its functions. Another hopper could still put stuff in here, but you can see you can lock it out just by powering it. So all these items are locked here, but if this redstone block were to move over here, this hopper would be locked, but this one would be free to push all its items in there. You can see they're just feeding into each other. And we've got comparators that are reading whether there's something in here or not. So currently there's nothing in this one, so this one's not lit. And currently there is something in here, so this one's lit. And what these do is these are sticky pistons. It just pulls the redstone block back and forth as the time goes. So all of these will have to go here, and then when this switches over, they'll all feed back, and that will be one full cycle. So right now I have it locked on, but if I turn this off, you can see the block automatically moved. All these are going here. As soon as the last one drops out, boom, that retracts, causing the blocks to now feed the other way. And it just goes back and forth, and you could have your redstone coming out of various points in it. Like you could just have one of these feeding into whatever circuit, or you could have it coming off of here or wherever. I guess let's build one real quick. So what you need is a hopper. Crouch and right click to feed them into each other. You'll put a block next to one of them. You need sticky pistons. Let's see if I can. Okay. Then you need some sort of block. Oh, I needed a comparator. I don't know why I got rid of that. Comparators coming out of here and into blocks. Sure, why not? We'll use that. And then here, here, and then a stack of items. Do that. After putting in a stack, the items will go from one to the other, and you can see that as soon as they feed out, this will move back. Boop, and it just goes back and forth. You'll notice that both lamps are lit up. That's a little misleading. I should have used normal blocks. But the reason they are is, again, because they are turned off for such a short amount of time before being turned back on that they don't actually have time to turn off. But you can see both of these always have items in it, except for that, very short amount of time where the last item has gone into one, the comparator turns off, and as soon as it does, it will retract the piston, bringing the block back to it, and the cycle will go the other direction. Alright, let's talk about logic gates. Logic gates are something where there are multiple inputs, potentially, and an output based on those inputs. So we can see here there are a lot of different types. I'm only going to go over 4 of them here, and I'm not even going to go over all the variations of them. You can build them in different ways, you can have them skinny or wide and flat, different things. There's different benefits and disadvantages to each of them. You can see here it's an AND gate where both of the inputs have to be on. A and B are on and the output's on. So that's the sort of thing we're talking about here. This is a very simple AND gate where the output is dependent on both of the inputs being on. So what's going on here is if we get rid of that redstone, you can see this torch is on and it's on. But if we put this redstone dust here, both of these torches are powering the dust, causing the torch to turn off, which makes the lamp turn off. So once you've built it, once it's in its native state, the lamp is off. When I put both inputs on, though, these torches will turn off because I'm powering the blocks they're sitting on, which allows the output to come on. So if we build one here, it's real easy. You do 3 blocks. You're going to need a torch there, there, and there. Redstone here. There's your output. There's your input. AND gate. Very simple. If you wanted one that instead of being flat and wide was tall and skinny, then this would be the way to do it. So in this case, I could build this and have another one right here and another one right here. So I could have a whole row of AND gates in a much tighter space, horizontally speaking, than doing this. And it just sacrifices a little bit of verticality. So this works exactly the same way. You've got a torch here. If this torch is on, it powers through the repeater through the block. If this torch is on, it powers the redstone dust, powering the block. So both of these need to be off for the light to turn on. So exact same thing, just a slightly different way to build it. This next one, this is an OR gate. You can see OR gate. So if this input or this input is on, then it'll turn on. And this may seem like a silly one. Both can be on, both can be off. Normally we don't need to discuss this being an OR gate. There's just certain situations where you need something where you're like, oh, if either one of these is going on, I need it on. So you don't always need to think about it like this, but I've used them before. This one right here is a NOT gate. All this does is whatever the input is, it reverses it. So if the input's on, the output's off. If the input's off, the output's on. I hope I said that right. But it just inverts it. And it does this by having a torch, which again is always on unless something turns it off. So you attach that to a block and feed redstone into it. So if this turns on, it'll turn off the torch. So this is a very simple inverter. Here we have an XOR gate. So this is kind of like an OR gate, but it's a little bit different because it's an exclusive OR gate. That's what the X stands for. So only one of the inputs can be on. If both of them are off or both of them are on, no output. But if one of them, exactly one of them, is on, then the output is on. So in this case, you can see if I flip this one, it's on. If I flip this one, it's off again. The great thing about these circuits is that every time there is an input to either input, the output changes, which can be useful in some situations. So I'm not going to explain how this exact one works, but I've got another one I want to show you. It's slightly easier to explain. But here is my house. I left the door open. I'm not a builder, so don't judge my aesthetics, but if we walk in here, the lights lights off. If you've ever been in a room like this where there's two light switches, this is how it works. It's an XOR gate. So if I turn flip one of the switches, it'll turn on. If I flip the other switch, it'll turn off. I can flip this one on, off. And so if I go through here, and by the way, this is another, just a quick tip you've probably seen before, but if you have trap doors here, it treats it as a full enough block to be able to put a painting on, but then, you know, you can obviously walk through it, so it's sort of a hidden wall. So this torch or lever is on the other side of this block, so it turns this redstone torch on and off, which allows us to send the signal up to the ceiling. If we go through the fireplace and through the chimney a little bit, you can see that's the chimney. Well, there's too much smoke, you can't see it. Block the smoke. Yeah, that's the chimney. You can crouch and go through here. This is where the inputs are coming through. So this is that torch that's coming out of there. That's one of the inputs. The other input is coming up through, we'll just break this real quick just to see it, coming up through glass. So there's the redstone torch. Its power would come through this redstone dust. And glass, stairs, slabs, those are all transparent blocks in Minecraft. So redstone signal can travel up through them. The block itself isn't powered, and so the signal can't travel down through them. So that's why I can have this where it looks like the redstone is being cut off by these stairs, but since they're transparent, it doesn't. If this was just a normal block, that would be cutting off. But if I can get in there, there we go. Stairs there, so it's got a solid bottom and solid side, so it looks like it's a full block, but it's not. But anyway, so those are the two. Let me get rid of this so we can see it a little better. Those are the two inputs, and I'll try to explain how this works. Basically, the redstone gets pushed through the block and to the side here. It also, because this is lit, this is a powered block, the redstone here is powered, and these comparators are in subtract mode. So when you put them down there in comparator mode, you right click, the light turns on, they're in subtract mode. So now what they do is they take the back input minus the side input. And since the side input, if this one's on, the side input is going to be powered at 15. So no matter what this is, it can only go up to 15. So at its very maximum, 15 minus 15 is 0. So you can see that this one is not lit. Whereas this one, since it's not lit, has 0 here. So this is 15, 14. So 14 minus 0 is 14, which is good enough. So if this one were powered, you can see that this would also be 15, which would mean both of these are minusing 15, so they're both off. I hope that makes sense. We can build one real quick, and maybe that'll help. Where's my stuff? So this one's actually really easy to build, even if you don't understand it. You do two comparators. You need to right-click to turn them into subtraction mode. We'll need redstone dust in front of it, to the side of it, behind it. Boom. And then we'll do a block. I'll put that there real quick. And then a block here and here. We'll do a repeater here and here. So if one of the inputs is on, if both of the inputs are on. There you go. So now I'm going to show you a trick that I've shown before, which is a hidden hopper minecart. So this is cool if you want to have a flat surface of any kind and just a hidden input. You can drop something here and it sucks it up, and boom, it ended up in this chest. And the way this works is that we have a minecart hopper right here, which will suck in the items, but it's hidden inside of a block. The way to hide it inside of a block is to place it down. So in order to place a minecart, you have to have a rail. So here, we'll put a rail down, we'll put the minecart on top of it. Ooh, well, we really want it to be this guy. Then you can see the hitbox down there. We want to destroy the rail. If you don't do that, then when you push the piston, the entire rail will move. So you get rid of the rail, then you have a block with a piston, and you push the block down into the same spot. And you can see it becomes dark because the entity's colliding with the block, so there's a shadow around, which is why you need to somehow disguise it with some other stuff so people can't see the weird shadow going on there, which is why I built this little thing here. Okay, so the last thing I'm going to talk about in this video is an item filter. This is used in a lot of sorting systems. This is also used if you want to check, maybe you have a key, they have to throw it in. Could be a secret thing like we just saw, or it could be clearly like a chest to put it in, whatever, and it detects, is this the correct item? If so, do something, otherwise it won't even suck it up through the hopper. Here's the output chest, here's a filter, so you can see we have 44 blocks in here, and these just need to be filler items. So it's good if they're labeled as, and these could be anything. This could be junk. This could be dirt labeled with some random number on it so that you'll never throw another dirt with a random number on it in your system again. That way it won't accidentally grab it when it's not supposed to. And you leave one slot open for whatever you want to program it with. So in this case I have this entire shulker box full of stuff. Let's say I've just gone mining. I got my Silk Touch pickaxe. I went on a nice mining expedition. So now I want to put the shulker box right up here and have it sort out the most important thing. So I'm going to grab this redstone ore, put it right here, and then when I put this box on top, only the redstone ore is going to get pulled out, and all this other junk is going to stay in here. You can see it's just pulling out the redstone ore because it's filtered. It gets pulled through here. There'll always be one in here because that's the way it works. It'll go through transit, and then boom, you can see all my valuables are ending up in this chest. So the way this is sort of working is this comparator is detecting whether this is full when this only has the one block in it and not, let's get it to stop here. Yeah, so you can see when I stop it, it's still got one in transit. You've got the one that's obviously marking what it wants to filter. So when this has 45 items in it, the 44 filler items plus the one item to indicate what you want to be sorting out, the signal from the comparator will be 2. When one more item goes in there, which is going to be, one more of the thing you're filtering, because that's the only thing it can suck up is either your filler items if you accidentally throw them in there, or the item you're wanting filtered. That'll increase the signal strength by 1, so this will go from 2 to 3. Once this is lit, that'll power this block, the repeater will push it through, turning off this torch. This torch is always locking this, or powering this block, locking this repeater, or locking this hopper. So this hopper up here is feeding into this comparator, so it's not going to try to push out its items anywhere because it has nowhere to go. So it's just sitting there holding items. It'll suck out items from here if they fit, but that's it. This one wants to suck the items from here and put them in this chest, but it can only do that when you unpower it. Right now it's locked. So whenever that condition is met, whenever one of these drops in here, boop, 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 it unlocks this, allowing one more item to be sucked in and one more item to be pushed into this chest. And that's an item filter. So I'll show you how to build one real quick. Let's see, what do we need? I'm going to need one of those. I'm going to need probably one of those. Probably one of those guys. And I think that's it. Okay, so like a lot of contraptions, we're going to do this nice V-shaped thing going on here. Then we're going to do this up top. So we've got our comparator coming out of it, just in comparator mode. You just set it down. You got redstone signal, or your redstone dust here, sorry. Your repeater is going to go here. Oh wait, I don't want a delay on it, do I? No, don't need a delay. Then you put your torch here. You're going to need a hopper. You can crouch and right click on the comparator to put one down without changing the comparator. We're going to need a chest right there and a hopper feeding into it. And then here we can take whatever filler item we want. And I'm going to need 44 of them. No. 41, because that makes 44. And then whatever the block is, let's say we want that. Okay. So now if I toss one in the top, boop, it went down there. You can see they all ended up down there except for the one in transit and the one that's doing it. So, pretty easy to build, pretty useful though. Like I said, you could have this be a key. You know, maybe in my castle escape room, I have an altar where there's a block. Currently, it'll be something cooler later, something plot related, but it's a block with a certain name on it or a number or whatever. And when you toss that on top of the altar, the hidden Minecraft hopper, Minecart hopper, sucks it up and then puts it through an item filter so that if it's the correct thing, it'll go ahead and do something, which in that case is open a stairway down to the catacombs. So that's all I have for today. I hope that this was helpful. I hope that some of these can be useful to you. If you have any questions, let me know. It's really hard to explain this stuff well, just to a camera, not to an actual person, and hope that the people watching on the other end can understand what I'm saying. I also had some difficulties with recording it. I had a lot of bits where I thought I was recording and I wasn't, so I had to go over a lot of it again. Hopefully that means I did it better the second time when I actually was recording. But if I'm, whatever. It's a challenge, but hopefully this was helpful to you. And yeah, I'll see you in the next one. Blah.